Hello, everyone. This is CSJ4 from Makerere University, and we are here to present to you an AI-based system for predicting commercial success of Ugandan music. I'm by the names of Katochi Vilige Agathon. With me is Batuka Samuel Aubrey. We have Kakembo Boniface and Opio Philbert. This project was due to the fact that we noticed that over 90% of Ugandan music is released by independent artists who operate without AR support, that is, without support of any big organizations, and these incur expensive costs in trying to produce a standard product that can really penetrate the market so that they make some money. And with no commercial indicators like AI systems, these struggle because eventually they don't know whether the song will be a hit or not, whether the song will actually speak to the people's minds. And this leads us to a problem statement saying that these independent artists lack affordable objective tools to evaluate rhythm quality and lyric message effectiveness during early stages. And we acknowledge that there exist systems that have been developed to try to tackle this problem, whereby an artist is going to produce a song, but then without knowing whether their song will actually speak to the masses. Okay, and then also these systems currently just provide a prediction score. Okay, they provide a prediction score, but then we we think that beyond giving a person a prediction score, what about if you go forward to provide recommendable action? That after giving you a prediction score, that let me say this song will be, let me say 70% a hit. How about you go forward and let me know of what I should improve in order to make this song a good song before it is actually released to the people? So first, we are looking at providing a solution that is going to come before production, like before a song is released. And we acknowledge that some of these current systems only come to play after a song has been released. And this can basically help no one since a person has already invested a lot of money. And we noticed that several techniques have been used to try to tackle this problem. For example, we've seen tools that have used the approach of random forest. We've seen the approach of neural networks, which we've seen the approach of neural forecasting. And for neural forecasting, here, this provides the greatest accuracy of about 97, but it's too expensive and it needs a lot of human labor. So when we looked at the current systems, we noticed various gaps. Number one, many of them don't provide actionable feedback. They will stop on the point of giving a prediction. Number two, there is no there are no models that specifically handle African data, that is African songs. And for our use case, we decided to go with Uganda. There are no tools that specifically target the Ugandan music industry. Thirdly, we noticed that most of these focus on the post-release after the production. And here, by then, a person has already invested a lot of money. Number four, inaccessible costs. The current tools are very inaccessible due to the fact that they are very expensive. And the number one, what I would call the main gap is most of them are only Western based. They are English only. So there is no tool that specifically handles the local languages for Ugandan artists. And that's why we came up and we developed this system. While undertaking this project, we had a general objective, which was to develop and deploy an AI-driven music evaluation system that predicts commercial success potential by analyzing rhythm quality and lyrical message effectiveness, whereby providing Ugandan independent artists with objective, culturally relevant, actionable feedback. And then we went forward to break this down into three specific objectives. Number one was extraction and quantifying of audio features. And for this case, we were extracting 52 per given masterpiece, and then 19 lyrics features using Whisper. And our second objective was to develop an interpretable machine learning model. And then number three was to build a full stack system. In this basically is a conjunction of fast API backend and React for front end. So at this point, allow me let my colleague take you through the methodology.
Thank you. My name is Opio Philbert, and I'm taking you through the methodology of this project. The project started with a three with a agile process, whereby it was iterative in a 2 week, more than 2 weeks. Each phase acted like outputted and input for the next phase. At our phase one, we started with the data collected by audio data from Ugandan music was collected from YouTube using the YCDLP algorithm. Then passed through a three-file normalization script, and the browser was used to extract 52 audio features with the Whisper automatic recognition for lyric transcription. We used the project used a VADA plus TechStat for 19 lyrical feature sentiment analysis. And then the project, before the model development, the dataset was explored deeply to break out the insights and the several patterns that lay in. This was based on statistical comparison and model selection, then hyperparameter tuning, regularization, and maybe setting the threshold. At our phase three, this was now the deployment and the system implementation where the React and self-explainability engines were designed. Now, this is just a system architecture outlining how data flowed in the project, whereby we had a data pipeline layer, then the machine learning layer, engine layer, then explainability layer, and a back end layer, plus the front end layer at the bottom there. So, as a data collection, this involves the manual process of downloading Ugandan music from platforms like YouTube, then together with the expert classifying which class, this hit class or flop class, then of course balance using different techniques for data balancing. At this is some of the features extracted from the data, which 26 male frequency, sexual coefficient, then other chroma features, plus now the lyrical features, which had a compound effect like positive, negative, or neutral. Then, of course, there were composite features, which were like derived from what? From other lyrical features. We followed an exploratory data analysis, which showed a distribution of the songs. We identified that songs that lay between 2000 were more, because we based on we classified them like from 2000 up to 2009. That was the specific category that we lay. Then also we continued by comparing lyrical features and audio features, whereby we saw that the lyrical features had more impact than audio features. Whereby the sentiment neutral feature stood out, be one of the most relevant features. We did a data balancing, whereby the club class had a 63% and the hit class had a 36, but we normalized them to 50-50. That is around that was 740 songs per class. Then of course we went ahead to use random forest giving importance to set the baseline, like select the top features that to perform in the model. Yes, we went through the project went through model development, and models like support vector machine, random forest gradient boosting, logistic regression, and stimulus measures were chosen for this task. And during the experimentation, gradient boosting showed a much more better accuracy than other models. And the project went ahead to choose gradient boosting for the deployment. During the model evaluation, still we saw that the gradient boosting was performing way better than other models. Then now, on our feature enforcement and self-explainability, we saw that sentiment neutral feature, which is a lyrical feature, dominated, followed by the unique word ratio and the concrete word ratio. Then the rest followed. And this showed that the lyrical features dominated more. So allow me to invite my colleague to take us through the implementation. Thank you.
Hello, my name is Batuka Samuel Obre, and I'll be taking you through the system implementation. For our technology stack, our front end, we used React plus Vite. For the back end, it is Fast API, REST API using port 8001. And the machine learning engine, we used gradient boosting V14, and that is sklearn. For the database, we are using SQLite and the analysis logs for the database as well. For the features, we use a drag and drop upload for, it could be MP3, WAV file, MP4, OGG, and it takes less than 90 seconds to analyze. We use a 36 feature radar chart for visual comparison of the track against dataset averages. We use the SHAP recommendations, and that's in plain English, prioritized by feature contribution, which is 84% of the comprehension. For the hit or flop, we calibrated probability with confidence score using dual Uganda and global models. Thank you. Let me invite my colleague.
This is Joshua, and I'm talking about the results, all the validations and the conclusion of our project. Now, we obtained a 75.7 accuracy, where the AI correctly predicted whether it is a hit or a flop of almost 76% of its time. Now, an 81.1% hit recall. Now, this is a very, very good for a person who has put maybe the audio to be tested for testing whether it is a hit or a flop. The 81% hit recall, it gives a good, should I say, a good feature that the system works very well, because if the system uses, for example, 8 to 10 maybe audios, and it confirms that they are a hit, now it recalls that and it compares with the other incoming inputs of the audios to compare and give the success. That's now the last 72 satisfaction. This is where the artist highly recommends the system to their friends after its success, after using it successfully for over like 72% and plus. Recommendations were made to friends and the what of you. Now, original contribution, or the reason why this matters is, number one, first for Ugandans, this is the first music AI trained specifically on 1,480 Ugandan tracks as a data set of 1,480 Ugandan tracks, and it gave a success of 75.7 as success. Now, another reason why this matters is the lyrics dominance. In Uganda, lyrics drives the commercial success. at a massive of 74.7 rate, which is different from the Western music. It also needs to learn local languages like in Uganda perfectly or better. And in the future, in the next years, we'll need to add the local language support, expand to Kenya, Rwanda, and other countries like that to solve that problem. But as currently, we did the testing on real world or unreleased songs. Like we did the testing on like 30 unreleased songs, and we obtained a success of 81% accuracy. The 30 unreleased songs were from the local music in the community and achieved an 81% accuracy rate, which provides a culture trained module much better than the standard global module. Maybe that's all for the conclusion. Thank you so much.